My name's Sean Paul Taylor. I'm the team lead for gaming R&D at BlackBerry. This is JAM389, and we'll be going over porting Android and iOS games to the BlackBerry 10 platform. And, there's my email and Twitter if you want to contact me. At RIM, I used to work, I've been at RIM for now BlackBerry. I was at RIM for 8.5 years, I guess, and at BlackBerry for another couple months now, or a couple days. Previously, before this, I was in charge of advanced graphics, working on OpenGL ES is an area of expertise kind of that I do. And now, since then, I've been working mostly on porting big game engines, middleware software, open source projects, people's games. Depending on who you are and how important you are, sometimes you'll get my team, sometimes you'll get developer relations. So today we're going to go over the BlackBerry 10 platform and the tools that you can use. Talk a little bit about the cross-platform development, hopefully some best practices. We'll go over native game porting, and we'll try to do a comparison between iOS, Android, and BlackBerry 10. Then I was going to do a demo. I'm not too sure if we're going to do a demo right now. And then we'll do Q&A. So a lot of people have a lot of questions about the new device. It's based just like the playbook was. It's built on the QNX operating system, which is a neutrino real-time operating system, microkernel-based, POSIX compliant, and it's very easy to run C and C++ applications because that's what it was meant to do. The operating system really at its core is Linux on steroids, I call it. It does what it needs to do, and it does it very well. Most people are impressed when they actually get their hands down to the actual libraries and see how things were done on the operating system. They're very impressed with how we do the operating system in the libraries. A lot of people who are familiar with kind of like Linux development or a development environment like that, they're very happy with the tools in the library and the compliance. So the tools that we have, first of all, the development environment you can run on Windows, Mac OS X, or Linux. So if you have a development environment that you like, those are the ones. The GCC compiler is 4.6.3. I think that's been updated actually. 4.6.4. GDB is 7.3. So, pretty much standard kind of Unix environment for compilers and debuggers. It comes with device deployment tools, so which are a set of command line tools for compiling, you can see, and then also for deployment, for signing, for packaging. These are all command lines. So the SDK at its heart is a set of command line tools. We also ship with VMware Simulator Images. So all you do is you can go and get VMware Player. You'll have to get Fusion for Mac, which is a purchase. So, but the images you just get from the development site, and you basically open the image, and it's a running device image, exactly as you would have when you booted your device up. If you want to do kind of IDE-based development, we have an Eclipse CDT-based IDE. It's called Momentics. It works on all the operating systems, so it'll work on Windows, Mac, and Linux. We also have, at the bottom down there, you'll see that for Windows, we have a Visual Studio plugin. That's pretty recent. It's in beta, and the gold is coming out next week. So that works quite well, actually. A lot of game developers, they're used to using Visual Studio and very iterative development. Kind of like a practice that my team does when we're doing cross-platform game development is we'll actually do a lot of iterative development on Windows on Visual Studio. And you'll pull up your window, and you'll draw at the resolution that you think you're going to be running on your device. And then what you'll do is you then work on, you compile it back onto the iOS or on the Android on their BlackBerry code and just run and see how it works. Literally, if you do your code right, you can get it down to like literally 1 or 2 files per OS. For a project, as an example, I'm one of the co-founders of an open source game engine called Gameplay 3D. It's a cross-platform game engine, and I have one main file that's different on each of the OSs, and I have one platform file, and that's it. And it has all the callbacks and all the eventing back and forth. And so, iOS and Mac, they're platform macOSX.mm, because those two are actually going to be Objective-C, and I've got kind of like a class below it that'll have your public interfaces that are implemented, and the whole file is just if-deffed with each OS. So I think that you can get the code down, and if you do that, you can really be smart about making sure that you try to focus on separating the platform layer from the core operating system code. And I think that's where a lot of people have challenges when they're porting over. They didn't start that way. They either have a lot of Objective-C code, or they have a lot of Java code, so they didn't really break their code up in a nice way. So we'll talk a little bit about hopefully the untangling points where we can actually go through and take a code base that you have and find some familiar code points and hopefully find the corresponding one to BlackBerry 10. So by default, the platform is built with a lot of open standards. I mean, it's a POSIX compliant library set. It's got STL, you have sockets. These are the libraries that you're going to be using with a lot for some of the code, the base level core code. We have OpenGL ES 1.1.2.0. Hope you're all using 2.0 nowadays. You don't have to, but. We have OpenAL 1.1. And for imaging, we have libpng, libjpeg. A lot of times, if you have a game title that doesn't have a lot of graphics assets, you might want to consider just keeping them uncompressed. I mean, it's slower to load. One thing to think about is that with your games, I mean, you're really going to be loading quite a lot of images. So texture compression is nice to do. You don't always need it. If you're willing to take the load time performance hit, which I find is the thing you really get with texture compression, and the size, the physical size. So if you have Angry Birds, you might not need texture compression, right? I mean, the game might be actually, all the assets together might be under a small footprint that you're willing to absorb, and you have no lossiness at all. So, I mean, you actually get the highest quality image. But if you're having a game like Need for Speed, and you're going to have images flying by you, there's actually no point. There's a lot of reasons to actually use texture compression, and the loading time that you're going to get for texture compression. So I didn't put that on there, but that's just really, you might have to use some libraries to load PNGs, or you might have to actually write some code in your image class or your texture class to actually load into a compressed image and then use OpenGL. So for fonts, we have libfreetype. I don't know if everybody's using freetype. I don't usually recommend people really to run freetype at runtime. It's better to basically generate kind of like font pages for kind of your own texture-based fonts, or however you're going to do it. You don't really want to be parsing freetype, TrueType fonts at runtime if possible, unless it's like bootstrapping. We have XML and database libraries, and of course, math. So a lot of people that come into this, they have a code base, and some of you are already using open source libraries. I mean, a very popular one is Boost. If you're using scripting, you're going to be using Lua, or maybe V8 for JavaScript libraries. A lot of these libraries are already on GitHub. So these ones here, as an example, we all have on GitHub, and we have V8 for JavaScript. So depending on what kind of libraries you're looking for, I definitely recommend to go to blackberry.github.com. We have all the libraries there. They have already been ported for BlackBerry Playbook and for BlackBerry 10, and they've been updated recently. So you can just go there. Our goal is not to keep them there, just so you know. Our goal is to actually get them upstream. Sometimes there's process with the build scripts and working with the open source teams to try to get their code into their upstream components. So as an example, Cocos2DX, I mean, we are upstream now. Like, if you go to the GitHub Cocos2DX project, it'll say, go there. And so we're going to try to do that with all of them. But it's a good start. Sometimes we put these projects there so that we can start the port there, make sure it's working. We if-def some of the if BlackBerry or if QNX, in the past, QNX code. And that's defined to the actual upstream team so that they can look at that and go, OK, I'll accept that in, right? So we kind of have a breakdown of frameworks, libraries here. So how many people here do game development? Anybody? Yeah? Okay, cool. So one library that I've been playing with recently that I enjoy is this one called Recast. It's kind of like for navigation method and pathfinding. So a lot of times people, when you get into character physics and character collision and stuff like that, it gets tricky because the characters can run into each other or run into walls. And to do kind of like ray tests on the wall on physics, it's kind of expensive. So you'll end up writing a lot of code to, do a lightweight pass of trying to not collide with walls and come up with like a proper bounds of a character so that when he jumps, his arms aren't a good bounding. You need a good bounding box and you're not actually going through the wall and stuff like that. So a really good first pass kind of query to find out whether your character should be able to go into a place is pathfinding, and you can use navigation meshes for that. So you'll take a library in and you'll basically scatter the floor with kind of like a 2D grid, and then you can control ahead of time kind of like a grid of where the character can go, and you test against that, and it's faster. So just thought I'd point that one out. It's a really cool library, and it works on iOS, Android, and BlackBerry. So. Okay, so let's get into some of this stuff. So for cross-platform gaming libraries, you have a lot of different options. A lot of people ask me, should I do my own stuff? Should I use open source or everything? I mean, really what you're looking for is to try to have the least amount of code to deal with at a platform level. And that kind of is challenging because even on the platforms, there's some fragmentation between the hardware or differences. I call it fragmentation because I don't like any changes. I want it to all be the same all the time. But I mean, you're going to hit iOS. It already has like 5 different resolutions that you're dealing with. You're going to go to an Android platform. You have, I won't even say how many different cases, but they have their own challenges as well. And we have a few now with the playbook, and we have now with the new Z10. We'll have 768 by 1280, and then 720 by 720 on the Q10. So you have a few different resolutions you have to deal with there. But I think what you have to try to do is deal with aspect ratios, I find more. And that's usually the key, is not to write code that deals with kind of like, this is the resolution, rather than focusing on scaling on the actual aspect ratios and dealing with how you're going to handle your game in those scenarios. So one of the scenarios on how you can handle this a lot easier is using kind of like professional frameworks that sometimes have mechanisms in here, like making folders at different resolutions, and you can drop assets. If you're writing a native app, actually recently you might have heard that they now support, in the Cascades framework, they support folders for 720 by 720. And so a lot of frameworks like these, so Marmalade SDK, Unity, Shiva, they have some mechanisms in there that allow you to do things like that. So at the bottom, the two, this is Gameplay 3D is a framework that I wrote with a colleague of mine, and we've gotten the team and gotten a big community involved. And Cocos 2DX is a really big community for 2D game development. So the bottom two are very good reference material for if you actually want to find out how to do something on one, and everything that I'm going to go through here, you can go back to those, cocos2dx.org and gameplay3d.org. The other ones there, the professional game engines, I highly recommend them. I mean, it's going to be worth it in the long run for you to actually pick up a tool like that and actually pay the money for the professional quality that you're going to get with those tools, and they really make a difference because they've already dealt with it and many people have gone through it. So if you do want to do it all yourself, these are the kind of reasons why. So why you want to consider starting with a design that's cross-platform by nature. So you want to make sure that it's easy to port all the code across all the platforms, and you want to make sure it's easy to maintain the platform-dependent code, so when new changes happen in the hardware, you can actually just go and isolate them there and test them on their own, and then build simple test cases that validate the platform changes. So the easiest way to do that is identify it. Say, well, let's take a logical look at the architecture of the platform, and let's identify and isolate these areas of the code and make sure that they're targeted inside that platform layer, and then we can build on top of it for the things that are hopefully not different. So one of the things you really need to do is consider, if you can use open standards, it's probably going to be one of the easiest things to do. As an example, OpenGL ES is available on all three, iOS, Android, and BlackBerry. So you're going to be using that code. That's a given. OpenAL, on the other hand, not always the case. So as an example, OpenAL is available on BlackBerry 10 and on iOS. And you can actually get it to work on Android as well. If you were to go to the open soft code base, that's basically the most popular one out there for open source. You can actually compile it for Android. Probably about 6 months ago, I got it compiling on there. And it was funny, I was looking on the web, and everyone's like, they couldn't get it to work on Android, and they had lots of bugs actually in the Android code. And then I built it for gameplay, and then people were downloading it from gameplay, even though it's like, we're BlackBerry doing this library, right? And I built the OpenAL for them, and people were picking up that one. I was like, okay, your build scripts weren't that good. That's all, right? So, but yeah, I definitely think that you could do all of your code in OpenAL. I mean, and it works on then Mac, Windows, and Linux as well, right? So if you use OpenAL, you're going to save yourself a lot of pain and suffering, and don't do like, their core audio libraries and stuff like that, and using like, and it's funny, if you use OpenSL, which is the Android API for their 3D software, the library all works, but you can't use 3D. Their libraries, the port of OpenSL on Android, actually from almost, I think it's like 95% of the hardware doesn't support the 3D interfaces or controlling pitch or anything like that, or gain. So then you go in there and you have this nice pitch control for like a spaceship that's flying, and then all of a sudden you run it on the Android and you're like, there's no change in the sound and the pitch. What's going on, right? And then I dropped my OpenAL library and commented out all the OpenSL code that I had. At first, we did an OpenSL, and then I'm like, oh, this sounds nice now. Okay. So don't even use OpenSL. Use OpenAL. You'll save yourself a lot of time. And then, we have these libraries here for imaging. And then Lua is a good one for scripting. And then another thing to use is to consider is for audio, when you're loading the libraries and storing them on, you might want to actually think about using OGG and using Vorbis for the encoding and decoding. It's a good library for just using kind of like a royalty-free audio compressed standard. It's MP3, you usually have to pay for this. There's a royalty attached to it. So, and other libraries people use sometimes that are not on here. So fmod. We ported the fmod, and I gave it back to Brent at Firelight Technologies. So that fmod has actually paid for the MP3 royalty license. So when you license fmod from them, you're basically also paying for the MP3. So if you want to use that, you can use fmod, which is a professional library that supports even more than OpenAL. Like it supports mixing. You can basically do voice and sampling, and it does a lot of caching of the audio, so if you're actually mixing different sound effects together. So, when we're talking about defining cross-platform, cross-device interfaces, we're really talking about methods that are going to deal with the actual hardware. So we're going to find out the DPI on the display. You want to handle a touch event, or you want to show and hide a virtual keyboard. Every platform will have their own way of doing this. And so, this is just I call this brute force, but that is the way I did it, actually. So, in some of ours, so you'll end up writing kind of like these classes or these code bases that actually separate off your code for each operating system. On iOS or on Mac, you're going to have an Objective-C.mm extension for C++ and Objective-C, but you'll be able to put C++ code inside there as well. So here's kind of like a just typical architecture. I didn't draw this, but my colleague who was supposed to present this did. Mine are prettier than this. No, just kidding. I think this is a really nice breakdown of it, though. So you have your game, and the game is just your game code. You have a typical device, and so for the device that you have, you're going to have some device code in the platform layer down there. So that's the platform-dependent code, and then you'll have a main, which they differ, actually. You don't really almost have to have any code in the main for most of them. Usually it's like go off to the platform and enter a message pump or something, and that's about it. And that's usually where, that way you can, there's nothing really to be needed. You can delegate right out of there. So sometimes it's one big if-deft main, or you can have like 4 files that have a different main in each of them. Usually need at least 2 because of iOS needs a MM file or an M file for their main. So on iOS, the SDK is Objective-C based development environment. You can also put in C and C++ code. And it's very easy if you already had code in iOS to go multi-platform. A lot of people, even when they were doing Objective-C, they quickly started to move code out of Objective-C area so that they could actually be more productive. So they'd actually take that code off. And now I'm not going to say that I don't like Objective-C or anything. That's not what I'm trying to say here. I don't like Objective-C. But it's a very interesting language. So I think there are people out there that might have already separated that code from each other and gone and done a lot of C and C++ code and early ejected away from the Objective-C development section. So most code bases that I've seen that I've ported, it was really easy to go multi-platform from the Objective-C code on iOS. In Android, this is a very interesting environment. And I know this area very well because BlackBerry kind of had this kind of design a little while ago. I remember when I introduced the first float over JNI at BlackBerry many years ago because we couldn't actually pass a float across. That's how dated the actual VM was and stuff. So one good thing is that the JVM environment was updated with Android. It pretty much is full big Java. They use a standard JNI mechanism pretty much. I mean, you generate your stubs from basically JNI interfaces by defining native, and voila, you can build a library in the back that has all your native code. Now, that being said, there's some places in Android that you cannot do that, and they don't have the libraries available. So you end up having to make wonderful JNI calls to do invocations on, Java methods from your native code, and that can get dangerous. So you have to guard it in several ways. And I think Android's going to try to improve that and say like everything you can do in Java, you can do in native. And I think I can tell that's kind of the route that they want to go, but they kind of put their foot in their mouth a little bit when they said we're going to support native, and then they're fighting with the back struggle that we went through, and we're not going to have to deal with that anymore. So. The good thing is that a lot of games out there don't have a lot of code in the Java. There are some Java games out there that are written fully in Java and use OpenGL, but a lot of the more experienced developers, they use basically a full native activity paradigm where you bypass the Java side of it, but some people do a custom view and make JNI calls. So there's kind of 2 ways to do it really when you do an Android app. You kind of have to be careful on how you do your loops in Android. And I think there's a couple ways to do it, but we'll go through the most common ways, and hopefully we'll identify some code that you're familiar with and that you might see and say, okay, I see that in my code. So with BlackBerry 10, pure C, C++ environment, we do have the ability to run an Android converted app onto the BlackBerry 10 platform through the APK kind of packager converter that we have. One thing that you can't do is we made a very kind of conscious decision that we didn't think it'd be the best thing to bring over native libraries. There's many reasons for that. The player, the Android player that runs on the device, has a architecture that's not as flexible. To do it securely and to do it in a way that's the most efficient and the way that's fair and doesn't actually run full, like basically Android, but kind of like a more constrained Android environment, also gave us some restrictions on that. But ultimately, I had looked at the code and I said, people are going to be more mad at us as well if we let them do that, because if they had seen the actual way that they could have converted the code over anyhow, they would have laughed and said, why didn't you just tell me that way? Because that's actually just as easy. And then they write the code that's pure C++ and decouple it out of their Android code, and they kind of clap their hands and say, that was amazing. It's so much less code anyhow. So I think most people, once they actually dive in and write the actual native, their first hello world, they can go back to their Android code and go, I can just take that code and plug that in so easily right now. And so they kind of can appreciate the actual environment that they have there, and that they didn't actually try to port an Android native app and run it on our player and like live with this kind of constrained environment. So it's kind of worth the cost to decouple there and come over and write the native code. And we wanted to make sure people were aware that that's the way we recommend, even so much that we've basically said this is the only way you can do it for an Android native app. So Android native apps need to be ported over to a native NDK app, and they actually all run, the apps run in their own QNX process, or BlackBerry QNX process. So they're not running on a shared plumbing inside this player. So for development tools, so an iOS app, you're going to use Xcode if you like iTunes. It's my I call it iTunes for programmers. It's funny, like my team, we're working on this cross-platform project, and so every time you hear some swearing in the area of our cubicles, it's usually some guy working on Xcode when it crashed on him about 4 or 5 times. And it crashes so often that there's a button that says, do you want to just relaunch? So you kind of, that's my joke, because I do work in it, and there's some good things in there, and don't get me wrong, but there's just some fun, quirky things I just find about that IDE. So some people just bypass IDEs. They're just like, I'm going to use, I'm VI, I'm going to do, Emacs, whatever you want to use. So you can obviously on any of these, I'm not going to say that you can. These are the IDE environments that you may choose to use, or the tools that you may use for packaging and debugging. So it supports full debugging profiling. It's amazingly fast. When you want to like deploy and stuff, good on them. Like literally, that's a good thing about iOS and Xcode. It supports obviously Objective-C, C, and C++, and they have an integrated simulator that works okay for games. I've run some of the same code in some game engines, and it just kind of dies in their simulator. They have all the form factors there, so you can run the different simulators as well. When you get into Android NDK, this one's funny. So there's nothing. First of all, when I have to teach someone on how to set up it, I bring over my experts. No, we all know how to set it up now. And people have forums on how to set it up. And they have basically no real direct native IDE support. There's some plugins out there that I've seen for kind of Visual Studio and stuff like that. We took a peek at how they were doing them before we did our Visual Studio plugin. We said, no. Those 2 guys in the shed in Poland that made that thing, no, they don't know what they're doing. Our Visual Studio plugin guys are actually top notch, so we're going to start it again from scratch. And so there's some definitely plugins you can get out there for that. Everything's pretty much command line. If you're really good at GDB, like I'm starting to be, which I don't like to have to be, but if you're like a good command line GDB debugger, this is what you'll be doing. You'll be using GDB in your debugger, and you're going to be really fighting with profiling tools. There's some profiling tools out there now I've actually seen the fact that they're not offering that. There's businesses being made on that software. And the standalone simulator is supported. I think now they just started supporting like OpenGL ES in their simulator, but for a while they didn't have that. So BlackBerry 10 NDK, we have an Eclipse-based CDT. It's getting better. Some of the things in there, you probably have some frustrations with Eclipse, like I do. I actually personally think that it's actually an okay environment. I think you're going to see a lot of changes from our team. There's a guy, Doug Schaefer, who works at QNX. He's the founder of the CDT plugin, and he's actually working at BlackBerry. So we've all given him the guns on the gaming team. We said, you need to fix this and this and this. And I think you're going to see a lot of evolution in that now that we're working so tightly with that, and we have access to that the code at that level. You're going to see a lot of innovation going into that tool set. There's not a lot of IDEs that really go cross-platform. There are some out there. I mean, the Qt Creator and a bunch of them. But I mean, that one's it's funny enough. I think they have the potential to be a minimalist framework, but it's not really that way. I mean, Eclipse by nature was like, let's throw every plugin you can in the world into a tool. And that was kind of like IBM, I think, kind of was the ones that they used that for consulting. And so that was kind of like the history there. But it was the tool that we were able to build on top of and write the plugin in a way that we were able to add the simulator and the SDK and everything in there quite cross-platform. So people like that. And you can actually have tools. So if you're familiar, plus also historically our development environment was Java. So some of the developers had some familiarity. Now, we didn't stop there because we're like, some people hate that tool. Forget about, we can claim that it's great, but I can't convince you. Like, this is a philosophical debate about which tools you want to use, and I'm not going to get into this. The bottom line is that a lot of game developers use Visual Studio. I went out there and we talked to like actually the game developers. I'm like, what do you use? What do you use? What do you use? And so like I would say a good breakup, it's like 50% people don't use an IDE. 50% of people do use an IDE. Out of the 50% that used an IDE, it was, if you were doing like kind of like cross-platform and desktop, you were using Visual Studio. If you're only doing mobile, a lot of people were using Xcode, actually. Because they were like, well, I have to compile in iOS, and there was nothing in Android, so you're kind of using Xcode potentially because of that. It's the only one that has an IDE out of the two. So we were able to make a Visual Studio plugin. The plugin you can actually fully do debugging inside there. Even with the update that's coming out next week, I think, or the week after, you can do attach to process even. So you can actually attach the live process and do debugging that way. You can basically do deployment, so packaging and deployment all throughout the IDE plugin. And so kind of the style that I do is I'll drop down the debug for Windows, and I'll run my Windows version of it. And then when I'm done, I'm like, okay, this works. Let me just verify that it's working also. I'll pick BlackBerry device out to the device, and then I can run it, and then I can play it on the actual device and make sure that the game's working the way I want. And we also support command line tools. So everything you can do in the IDEs, they're basically just layered on top of the command line tools. And the simulator, like I said, it's VMware. And the actual OpenGL performance is pretty good in there. I've run some things inside there, and it runs pretty good. Like you can run Quake at 60 frames per second if you go download the Quake 3 port and stuff like that. So, but there's some code definitely that the simulator starts to choke up on. If you use frame buffer objects and things like that, sometimes once you hit like your second frame buffer, it really starts to go down to like maybe like 20 frames per second. So for your game entry points, this is the Objective-C fun setup. You really just have this auto-release Objective-C where you're saying, this is my app delegate, and you're going to go there, and it's basically going to run this delegate that has all your lifecycle methods inside it. Nothing really complicated there. It's a main with some magical Objective-C in it. Android. This is for a native activity. So you're going to have your Android main, and this big Android app state, the Android app, that's a state interface that comes in. That's something that you can basically get a handle to other methods that you want to do onto the actual running application. Make sure you keep app dummy as your first line of your code, or it will do funny things to you. I just get a kick out of these. Like in our old I'll give you a history. So in our old JVM on BlackBerry, we had a method in there. It was called kick the puppy, which meant kick the watchdog. So I don't know if they accidentally, like, that was not planned, and we're going to leave that in. So you got to have an app dummy. But yeah, that you have to have that actual method there. Your app won't run. And then you have exit at the end. So the big dash in the middle is where kind of your code's going to go in. And then ours is that. So you don't have to do anything. It's up to you. If you put that in there, that will be your process will launch and come down and die. So inside your main, it's just like the iOS. So you can see that the code's pretty portable between the two for just that file. For game lifecycle, really this is where you're handling when your app goes in the background, into the foreground, what you want to do in those cases, whether or not you handle interfaces that are coming in like back buttons, whether you're going to handle menu buttons. So whether you launched and got options when you were launched, like parameters. So this code here is kind of some of the key ones that are inside there for Objective-C. So, you know, usually, like, this is the kind of code literally, like, you're going to put it in there, and once you put it in here, you're not going to change it too much. I mean, the goal here is just to make sure that you have these sections in there and you're handling the code properly. So inside here, you're going to see that, I'm going to go down here, handle background procedures. So if you had code for animation, you might want to pause the times if you're actually running application times. If you're going to be bringing it back in the foreground, are you going to resume your timers and things like that? So, and this isn't the way to do it. This is a way to do it. You can do it in quite a few ways, but this is just a pretty typical way of doing it. So on Android, you're pretty much registering for a bunch of callback methods that are going to tell you what's happening on the platform. And then from there, you're really going to have this thing called an event queue, which is happening. And it's going to give you all the events. So you're going to actually get something like this. This is your callbacks. So for if you want to handle an app command, which are basically messages that are coming in, you're going to actually switch on what the command is in iOS. And you're going to see kind of like an initialization, whether it terminates, resume, and pause. So that's kind of like the foreground, background, or lost focus, depending on the way you're going to treat them. And then you're going to go in and pretty much you're in a while loop. You're going to do your code and process it. So you can see that in this slide here, you're going to have some file that has this in it. Then you're going to have some file over here that has this in it. And usually have a while loop here. Inside in the iOS, you're going to actually have a message that's coming on your view all the time. So you can either do a paint or you can actually do a display callback. So on the BlackBerry, what we do is we have a library that's called BPS. So you're going to link in a library called libbps. And what that includes is it includes all the core eventing for the platform. It's going to have Navigator, Lifecycle events, screen sensors. This is similar to iOS as what's inside the UI kit. And then you're going to, the flow is essentially this. You initialize the BPS system, you run an infinite loop, and you pull for events. And inside the events, you're going to handle lifecycle events, input events, and everything is all inside that one loop. So this is what you basically see inside a BlackBerry native application. So literally the line above here would be your main if you want. You say BPS initialize. You declare an event that's going to be coming in, a pointer to this event. While basically you're running, what you're going to do is you're going to get an event from BPS, and then you're going to do a check on this domain that you're in. And so for Navigator events, you're going to switch on all the different Navigator events. So these are the lifecycle events. So if someone does a swipe down, you can handle a swipe down event. If you want to know when the window is going into full screen mode, or if you want to know when it goes into thumbnail mode, or if it's invisible, or if it exits. These are just all the different type of events that you're going to really deal with. And then when the app is closed, it'll pop out of here and it'll basically run BPS shutdown. So for input handling, once again, you're going to see a bunch of Objective-C functions that will be called. And these will be methods that are inside your view implementation. So on iOS, you're going to have usually a view. And the view, you can override methods inside that view. And so on iOS, these are the methods you would override to handle touch events. So you can see that's pretty much the code to pick up. And on the touch points, one thing to watch out on iOS, so the touch points for multi-touch, you're just going to get hash. And sometimes they're hash codes for the index because you get a set of fingers. So when you put your fingers down, the first finger is down, you're going to get a hash code for that. Next finger down, third finger down, you bring your second finger up, you move it around. Those will retain those hash codes for those fingers, but they're not indices. They're not actually 0, 1, and 2. They're like some magical hash code. You know, that's how they do their file handles as well, right? It's just magical hash code. And it's kind of frustrating if you end up porting code because BlackBerry would give you indices, Android you give you indices, and it would have been really easy for them to give you indices with a little like really low cost search. But there's code you can do. If you go to gameplay, we recently switched it over. We left them as hashes, and then we got into writing the code, and then it's basically throwing the nuisance onto the developer, and you have to deal with which finger, if you needed to know the finger. If you only need to know how many fingers, then that's okay. And if you're handling a game that has like a joystick on one side and the buttons on this side, then you don't care the order of the fingers at all. It's just like, if my finger's on this side of the screen, get the value of all of them, and you'll loop through all of them like that. Find the one that's on this side and say, that's my joystick touch. And then on this side, you're going to be like, if it's on this side, it's the fire button, right? And that's it. But if you actually have a game where you're doing swiping here, you're doing pinches, you're going to kind of have to determine which finger went first versus the other one. And just having a hash doesn't really help you too much. So you kind of need to know the indice and the order. One came up and one didn't come down. So there's code you can do to basically index that yourself. But it's a low-cost little search that you have to do. We just did an array, ripped through it and ejected out, and then found the indice, and then found the next open slot and kind of track whether it was up or down. And that's what we do in our platform and what Android does as well. So inside Android, this is what you're going to see. They have their motion events there. So you're going to switch on the different motion event actions, and you're going to handle, you know, up, down motions on the touches and key events down here. What was one thing I didn't like? One thing. Watch out for Android. Okay, Android when you're doing gestures. There's no gestures really. Gestures are kind of on the Java side. So to do gestures, you have to basically call Java functions to actually. So how did I do it? Oh yes, okay. You write a Java class in the view. You register it. You register in native the callback function for the gesture, and then you call your own class. That's the way you're going to have to do it in Android, and it's kind of a nuisance. I heard that they're trying to put gestures native. So, but just watch out if you're handling gestures in Android. It's kind of a nuisance. You might even just want to handle touch events and write your own lightweight gesture system for the things you need. Because it's pretty easy to write a gesture system. I mean, there is some cost on caches on the finger touching and tracking them. But I mean, if you're tracking the inertia and stuff, if some people just need swipes, like, you know, Fruit Ninja. I could just handle that, right? And when my finger's down, when it's going across, determine the inertia and figure it out. So you could just handle touch in here and basically build a gesture system in Android. So we handle all the inputs all inside here. They're all treated the same. There's a few I'm going to add on here that are not in this slide, and I'll give you some reference for it because it's new. I don't have it with me. Oh yes, I do. I'll tell you about that. That was actually cool. Magical toys. Oh, I'll get it after. I'll show you after. So essentially what you're doing is you're handling on the screen touch events. So everything on our input library is on the screen library. So this is not really part of BPS. BPS is a mechanism to allow you to handle the method through BPS. so that all these screen events can go through there. You don't have to handle BPS if you don't want. You can actually go and say get next screen event. So BPS was a layer we added on to make sure we consolidate all the eventing systems through one queue. So it does give you some benefits. So what you're going to want to do is you're going to just want to handle your events and do exactly what you have. So you can see, you can start to see common code paths here where your platform is going to be calling back to your game. And so it might be on your game class, you'll have delegate methods for every single one of these things that all the lifecycle events. You're going to have game.background, game.foreground, game.touch events. So you're going to handle all this code here. You're going to call your game.this, which will be common code base, and that way you can actually create a common interface across all the platforms to make sure that you deal with this in a cross-platform way. And then now you're just managing, and then you write a little test framework that makes sure that when I touch the top right, that every single platform that I'm getting a touch right at the top right-hand corner, and you do all of your testing. And you do all these kind of tests to make sure it's all working first before you go on, write this extravagant game that has problems with the platform layer, right? So one thing that we've added that's not on here, and there's a gestures library that you'll be able to have a gestures domain, and you'll be able to handle events as well that are, gestures is just an abstraction layer that deals over top with the touch events, like I said, and it just basically captures them, queues them, and manages the lifecycle of the touch itself. One thing we've added is gamepad events, which is pretty cool. So I kind of did an announcement in the press yesterday. We've added actually in the screen library the ability to handle Bluetooth HID gamepads. So you can actually attach, right now we're supporting the SteelSeries, which is like a high quality, they're kind of an enthusiast gaming device when it came to mouse and keyboards and stuff. They made like gamer keyboards and mice, so now they make gamepads as well. So we support their Bluetooth. They have this, it's called the SteelSeries Free. It's not free. It's like $79, but it's a pretty good, it's got 2 analogs. It's not free. my employee's like, I need to get about 8 SteelSeries free. I'm like, oh, go ahead. He's like, no, they're not free. So you get these gamepads, you pair them, and then all of a sudden they'll start handling the events. So it's really cool because you can basically start taking your device, hook it up to like a big screen TV, and then sit back on the couch and really like play your game. So we're telling all the game developers now, go out and start integrating this in. It's going to differentiate you from the crowd when you're selling your game. And we're going to be doing some promotional things, working forward for features in that category so that we can kind of overhype that and try to make it so that the users get the benefit, because the game developer, it's like it's chicken and the egg. I kind of need to kind of like give the users something. Oh, I can't. Okay, I got to give the game developer something. Okay, I can't. So we're going to actually definitely start promoting gamepad-enabled games if you actually hook that into your game, and it's going to make a difference. And so you can pair right now with the SteelSeries and also the Wii. So if you hold the 1 and 2 button, which is the HID gamepad mode, not the little red button for Wii pairing, you can pair Wii gamepads also, and you can actually get all the events. So a lot of we picked that one because a lot of game developers, they have a Wii kicking around at their. Everybody's got a Wii kicking around at their house. So we just said, oh, we'll support that because then at least that's one. And there's a whole bunch of hardware that's coming in the pipeline as well that we're working with now, because there's a big trend with this, with the Oya and all these kind of and NVIDIA Shield that came out and all these kind of. I think there's this kind of trend where people, they'd like to do more enthusiast-style gaming with their hardware, but our approach is that you kind of want that on your game. I don't want another device. I don't want to buy another Android gaming console. Like, why can't I just hook it up there, hook up the device, and then when I want to run, I can disconnect and take it with me, right? So that's going to be our strategy, is really just enabling what you could do there, plug it onto the TV. But yeah, I definitely try to put gamepad events in there. Okay, graphics and windowing. This is the fun part. Okay, so UI window, UI view, EGL view. So these are pretty much the classes. The view is going to handle all of your drawable interfaces and your callbacks on a lot of the touch events. And then the EGL view is basically your OpenGL context. So I just kept this really, really minimal. This is way bigger than this in real life. I mean, in all reality, this is like, give me the best. No one ever writes the code this way. but I'm going to skip over this one because I wanted to get to the BlackBerry and the Android one. Let's just say you're going to have some code that basically creates a context, an EGL context. So this is if you're using OpenGL 2. With Android, you know, they have a little different approach. It's straight EGL, and you're querying the window potentially for some characteristics on the attributes. So if you want to know DPIs and things like that to decide what type of resolutions you're going to want, but not really. Usually it's always going to create a full screen window, and so you're going to create a window surface based on, and you pass in state window as the handle to the window. So that's going to allow you to create a window surface, and then the surface attributes. Usually you're going to create a 32-bit 888 frame buffer, and then you may decide to add a depth and a stencil buffer. And usually, one thing to watch out for Android, if you have a device that has a Tegra 2 or 3, in their unwise wisdom, they decided to only support 16-bit depth buffers. So you can run into some precision issues. Sometimes people are like, this doesn't look nice, and it's like, well, it's kind of crappy hardware. So the hardware is actually good in a way, but it's got some problems with it in my mind that there's a bunch of these limitations that go up. We won't be talking too much about hardware and graphics in this talk. I just wanted to get you up to the point where you kind of have a common base. So they use EGL. EGL is an interface to create windows, surfaces, rendering contexts, and you basically make the two current together. So BlackBerry, we have our windowing system for actually creating the windows. Then you create a screen context, which is basically like the drawable context for a screen. Then we, just like Android, we use EGL for all the initialization. So this is how you actually create a screen context. You're basically saying, create me a screen context. Then you're going to get the window type. Then you're going to set the window properties. There's a bunch of properties if you want it transparent. So you don't need it to be transparent for a game. I mean, realistically, you're not blending. You don't want to do any compositing. You're going to want it double buffered, and then you get right into the same code that you have in Android. Literally, it's like EGL create window surface. You're going to pass our screen window instead of like theirs, and then when you're done at the very end, you'll do things like destroying the window and destroying the screen context. For file I/O, yeah, iOS has got a lot of Objective-C. So this is another area where you're going to probably want to write potentially a bunch of methods to do an abstraction around some basic file I/O, whether it's opening files, getting directories for files, things like opening a file and giving you back maybe like a opaque file handle. That could be a good way to do it, and then having methods to do reading bytes, reading an array of floats, reading array. Like you can just come up with like 20 different file I/O interfaces all across the different platforms. So the way that they get their application folder is through the bundle. The bundle is that magical file that is your running app and has all your resources packaged in it. It all looks like it's there, but you got to right-click in iOS and say show package contents, and then you'll actually find the resources. And then they have a file manager for doing a lot of other operations. In Android, there's not much. You just basically use pretty much standard file I/O. One thing to watch out for Android, the only thing you're allowed to really write to is the SD card. So whenever your app's running and you want to write out to, if you want to write out to, sorry, with standard file I/O, you can only go to the SD card to do standard file I/O. If you want to actually go into the device package or the runtime space, you actually have to use more specific, Android-specific interfaces for actually doing writing and reading from the actual runtime location. So in BlackBerry, We do it a little bit different. It's pretty much truly like a Unix environment. So the only thing that you have to watch out for is like this path. And so the little secret /s app native, you can actually get the current working directory. And then there's also a bunch of soft links inside the operating system. So you can actually just do /app/native. So your app always runs in a sandbox, and there's always a soft link inside the sandbox for file I/O, so you can actually go straight to app native if you want, and you can skip getting the current working directory. But if you wanted to get it, these are where they actually run. So if you're actually running inside the IDE and you want to know, oh, I see a sandbox, but I don't see where anything is, you can actually drive right into the actual accounts, 1000 app data, and then if your unique app ID was like, you know, Ruvio.angrybirds, like, you know, this is kind of what you could do there. And then the shared memory is there. If you want to actually write out to a shared, there's kind of like this shared access, so I mean your documents folder and things like that, or anything like that. What you're going to want to do is you're going to have to add a permission inside there so that the user knows that you're writing out to that place or reading from there. I don't think it's really necessary in most cases, unless you're writing two apps and they want to know a common place. There's no real reason why you need to actually use the shared data. If you have some background service and maybe they're writing to there, that would be another reason to actually use the shared. But in the shared, then you're going to need to namespace it, put your own stuff. There's the risk that the user deletes it on you. I don't know why they would do that, but the sandbox is a safer place. There's a folder that it gets put into called data. So for audio, like I said, OpenAL, I talked a lot about this, but typically a lot of people were using the AV Foundation framework. So there will be games that you need to do more than OpenAL. We did recently add on BlackBerry capture support on OpenAL. Our original port on Playbook didn't have capture. With BlackBerry 10, we enabled OpenAL capture, so you can actually use it as a capturing device, recorder. So if you have a game where you like, say this, or like, you know, Zelda when they're like, blow into the microphone, and you take the candle and it blows, and really all it is like a low pass filter for taking a sound. You might want to actually do capturing, so you can still do that with OpenAL. If you want to do sampling and you're writing a game like where you're actually a Rock Band kind of game, right now it's pretty challenging to try to get the capture, the sampling, and the processing, and then output back on almost all of them. iOS does a really good job at this. It's something that we're looking on, but okay, I have 5 minutes, so I'm going to skip through. I talked really long about too much. I'll get to more important stuff. I think I'm almost done anyhow. So in-game payments. So iOS, they have the StoreKit framework. There's nothing really on the platform level for Android, so there's a lot of different ways to do it. They have a payment API in Java, and we have a payment service. So there's a library for payment service. You pretty much set the connection enabled, and then it's all about just registering your app ID. For social gaming, this is the easy one. You can use ScrollLoop for everything. So ScrollLoop was an acquisition we made back, and it lets you do leaderboards. And there was a talk yesterday that was done on it. So I highly recommend using this framework. People are using this. There even is settings inside there for using Game Center through it. So if you use ScrollLoop, you can have Game Center integration actually on iOS. So there's some benefits there. And one of the things that we have on ours is you can actually get all the information, and then you can draw and skin the achievements how you want inside there. And we also have a games app integration. So you're going to get a lot of benefit from word of mouth through when you integrate ScrollLoop in. It's definitely worth it. And yeah, that's pretty much it. Thanks a lot. That's pretty much all I have for the talk. I just wanted to leave it open the last 5 minutes now for any questions. Pardon me?
I want to know if the native code is all reused for all platforms.
No, it's not. some people try, so the question was, is all the native code used across all the platforms? So I think that's why I try to say to break up the files. People struggle and try to make as much common code as they can, and I agree with that. I actually think you should try to keep as much common code as you can. Sometimes it's just easier to make that platform layer and try to duplicate a little bit of code here and there, even though it's file I/O code, potentially, or maybe it's code for some common input handling. That's why what I do is, even though you see handle a touch event there, I immediately convert it into a common normalized touch size. So if you want your touches there in screen size and you want to go to aspect ratio, send it into your game and then put that common code there. So at least send it in the native resolution value system. Normalize it in your common code, right? Don't normalize it because you're going to have the same code twice. So your code's not going to be all common. There's going to be definitely native code that's different per platform. So, is there any more questions? Don't be afraid. So I also have another talk later on today where I get into talking about some open source projects, open source middleware, about what you can use in your game. And I kind of do an under the hood over one of the game engines that I was the co-founder of and wrote a lot of the code in. And it's called Gameplay. So if you want to find out more about how to do an extension on the layers above this, come to that talk. It's at 1 p.m. today in JAM389. And this is my email now, or rim.com. Rim.com also works. And that's my Twitter. But thank you. That's it.